So part 2 of the video, continuing on from getting your trigger input. These boards, I'll explain, these boards were never built for spark control. They were not intended originally for spark control. They never changed the design on this board. You had to change it yourself. So spark control was done here. That's another pull-up resistor. So the negative symbol is the negative side of LED 17. I'm using LED 17 to trigger my spark. The resistor is there as a jumper to 5 volts. So you're gonna get a 5 volt logic level spark output. Once you jumper that on this old school board, you got underneath the board, there's gonna be a jumper wire tapped from this connection there. There's the wire jumping into a unused pin at this connector, and out comes your 5 volt logic level spark output, which goes back to the distributor to the power transistor. So this is what you call like a smart coil setup, that the transistor igniter is inside the entire distributor. So it only needs 5 volts to trigger. Then it grounds the primary winding of the coil and fires all the spark plugs. So that takes care of the input and the output. You're also going to want to, if you're running Megasquirt 2, you can get temperature sensor resistance. So a car that hasn't been done before, the temperature sensor, you're going to want to know the resistance of the sensor. She's using a voltmeter to check the resistance when the engine is cold, midway through warming up, and fully warmed up, on a factory running car. Start it up one morning. As it warms up, disconnect the sensor, check the resistance again. As it's fully warmed up, disconnect the sensor, check the resistance again. Write those 3 readings down. You're going to know the temperature by using infrared thermometer right on the sensor. So you get your temperature reading in relation to your resistance. You need 3 points: cold, warming up, and hot, around 200 degrees. With Megasquirt 2, if you have a Megasquirt 2 project, then you're going to type in those into the calibration tool. So calibrate thermistor tables, coolant temperature, 3 points, factory bias resistor of 2490. That's these guys that I have not touched. I have not touched those. Those are 2490 each. One is for coolant, one is for IAT. You want to run a GM IAT as much as possible. Tap it into the Megasquirt. Especially if you don't have a GM car with IAT, you're most likely going to have mass airflow. Anyway, so this is your coolant. You're going to type in your 3 temperatures that you measured it at and your 3 resistance readings that you measured it at with the Megasquirt hooked up, and write it to the controller. After you're actually hooked up, just save that information, save it onto your file here, and write it to the controller. And that should get you some accurate temp readings. That's what it's supposed to do. So you got now your temperature correct. You're gonna have to start worrying about actually getting the car running, which means you're gonna start checking timing and stuff. Because if you can't get it running, even though you have the right modifications, maybe you just have the wrong timing, and that could very well be. So before you even break out the timing light, you want to make sure you got accurate timing marks on the engine. If you got an old beat up timing cover that's made of plastic, that's kind of distorted, then you're gonna need to make a tool, buy the tool to find true top dead center. Just have a long skinny screwdriver, pull out spark plug for cylinder number 1. And just put it down the spark plug hole. Rotate the engine clockwise and watch this guy come up. As it's coming up, the point where it stops coming up, that's TDC. Now, there's going to be a point where you're still rotating the motor, but this is not moving. That's as the piston comes up, you're still rotating the crank. There's going to be a pause before it comes down. Now, that can seem like a lot on the crank. If you want to get overly critical, you can, but as soon as it stops moving, for me, that's TDC. So I leave the motor as is. Don't touch it, don't crank it. You have true TDC. Like I said, we're doing this because, for example, you have bad timing marks to begin with, which means you got to make your own timing marks. This is a tool right here. I got 3 of these made for different engines. This one is my GA16DE. So it's a piece of folded over masking tape. This, what you do is you wrap it around your harmonic balancer. If your harmonic balancer, in my situation, was had a damaged rubber dampener, this thing started spinning around, so the timing marks moved. They changed location, so I couldn't use them anymore. So obviously this is a little different than a GA16DE, but this one didn't go bad, except this engine doesn't have traditional timing marks. It's timed for cylinder number 2. I want cylinder number 1. So you get this, you wrap it around your dampener all the way around. You make a clean cut. Once it reaches all the way around, make a clean cut. You're gonna take this, get a good ruler, measure it, measure the length of it, divide it by 360. Once you get 360 divisions out of this, every division is gonna be a degree. So if every division is a degree, I'm gonna take the first 5 divisions and call it 5 degrees. Another 5, it's gonna be 10 degrees. 5 degrees before top dead center, 10 degrees before top dead center. Those are gonna be my timing marks that I'm now going to transfer over to the harmonic balancer. And I'm gonna make my marks with some whiteout, with a whiteout brush, and take a file and scribe it permanently. Scribe it permanently so that now I can use a timing light and it'll shine pretty good on whiteout. So that's how you make your own timing marks. If the harmonic balancer spun around, if the timing cover distorted, you know, the issue is on that side, then you're gonna have to make a new point of reference on the engine. Since your timing marks are distorted on the engine, you're gonna have to use something else. It could be a casting mark, it could be anything. This one has this groove, so I use this groove as a reference. So when I flash the light and it hits my timing mark, I want it to line up with here. It can be anything, it could be here. On this engine, I got it off the bottom. I just put a little notch here somewhere. I think that's it. One of theirs. Yeah, maybe that dot, that dimple there is my reference. So I was checking timing from underneath the car. Literally underneath the engine like that with a light. And here's my marks. TDC, 10 degrees before. That's all I needed to know. TDC, 10. So I'm gonna have to make another video So this is part 2. Let's see how many more it takes.